Hi there, I'm Mrs. Trumble, and this is the beginning of the year. So welcome back to school. This is also the first video of our first chapter that we're going to be learning together in 6th grade, and it's all about computation. So we're going to be adding, subtracting, multiplying, dividing decimals. We skipped 1 and 2 for right now, and that is because it's easier to start out the year with just some basic ways to make calculations with these operations. We're going to go back to chapter 1 after we're done with chapter 3. Just a little note on how these videos are going to help throughout the year. They're for you, the student, and they're for your parents as well. It's also going to be helpful to review as we move on through the year. Say you forget something that we've taught and worked on in class, you can actually go back to the YouTube video and find the material and review. It's also great if you happen to be absent or if you have a lesson and you need to catch up on the main ideas of what we're doing in class. So I really hope that these videos are helpful and they serve to be a starting spot. We are going to be doing mini lessons in class. I'm going to be teaching in class as well, so whole group and small group. And that's what the great thing about doing this kind of flipped classroom is. You get a taste of the material at home for homework, and then you will come to class and actually dive in deeper together. So here we go. The notebook that you're going to need, that composition notebook that we've been working on in class, this is the table of contents is what's going to be filled out first. And I'm going to typically type it as you see here. And you're going to have to just fill that in your table of contents before we get started. So we are going to be on page 5 and 6 in our notebook. And the two topics that we're going to be dealing with is estimation versus rounding. We're going to do that first before we dive into the real lesson, which is adding and subtracting decimals. So go ahead and write that in. And here is the notes that you received in class. This is a copy of the same thing that you have in front of you. So make sure you go into your envelope or your folder and get out that sheet that I gave in class. That's very important to have. That is a check for me that you're filling in the blanks as I'm going along and teaching, and so that you can have something to refer to as well. So the first thing I want to go over is this idea of estimation, and it's different than rounding, and I want to just distinguish between the two so that we have no questions when we start to estimate later in the chapter. Estimation is involving your brain. So there's not a lot of paper and pencil involved in estimation, and you want to use easy numbers. You don't want it to be, oh, I have to write that down, I have to figure that out to be the estimation. And it should be something that you're doing first. Oftentimes kids see, oh, estimate, and they do the answer and then they round it. That's not what estimation is. Estimation, it's using your brain and it's using easy mental numbers. And that hashtag is not a hashtag, it's actually a pound sign. When I use this symbol in the future, then you'll know that that means number as well as hashtag. Also, with estimation, it has no specific place, value, place. That's what this stands for, place, value, place. The key word that you will see throughout the year that lets you know that we are going to be estimating and not finding the exact answer is the word about. So that's the last thing you have to write down. The word about means, ooh, we're going to estimate and that's it. Sometimes we'll have to estimate and then find the right answer as well. So all of this is different than rounding. So rounding, the place, value, place, is almost like a direction. So that's the word here that we're going to fill in. The directions are given. So it'll say something like round to the nearest tens place or round to the nearest hundredths place. So that's the direction that you'll usually see associated with what is asking you to round. Here are the rules. If it is 5 and above, we're going to bump it up. This should be review. And then if it's 4 or less, we're going to keep it the same. So keep it if it's 4 or less, bump it up if it's 5 or more. Here is an example for us. So the number is 9 84/100ths. We are going to round this to the nearest whole number. That's a place value place, and it's talking about the ones place. So here's a trick that I'm going to show you. I like to actually show as much of my thinking on paper as I can. You're going to hear me say show your work a lot in class this year. So one way we can show our thinking of how we are rounding and to keep our place values straight is to circle the place value place that we're talking about, that's the 9, and then draw an arrow to the next number to the right. That arrow that we draw our number to is what we then use these 2 rules for. So if this number is above 5, we will bump up the number we circled. If the number that we're pointing to with our arrow is 4 or less, then we keep that number the same. So it's just a way to help us figure out which number is allowing us to round and not, and then what number actually changes. The circled number is what changes if it is above 5. And this is above 5, which is now 10 is our rounded to the nearest whole number. So all this business about estimating and rounding, I had you take notes on first in order to be successful with the actual operations. You're going to see in your math books and in examples the directions of estimate first. And we do that so that we know our answer is actually reasonable. So here are the second bottom half of the notes for adding and subtracting decimals. So the first step is to estimate. We're going to get an approximation so that we know when we actually get our answer, if they're close, we're probably correct. Step 2 is to line up our decimal places. When you set the problem up, you want to make sure those decimal points are right in line. We can use grid paper, or we could turn our lined paper sideways. I'll show you those pictures in a minute. The other thing that we need to keep in mind when we're setting up our problem is to annex zeros. A-N-N-E-X. This might be a new vocabulary word. Annexing zeros just means if there are any gaps, if our numbers around the decimal point are not quite lining up, and there's some gaps, and I'll show you what I mean, we need to fill those gaps in with zeros so that the place values are the same. Then, after we've set it up, we're going to add or subtract, and our final step is to check. The reason why we are estimating is so that at the end we can check with our estimation and make sure that it is reasonable, meaning is it close. So again, with this annexing vocabulary word, I want to explain this a little bit more. Why are we having to annex? It's so that our numbers have the same number of place value places. And I'll show you with this example. So this is an example that shows you what lining up the decimal places does to an answer. And we have the 4 8/10, and we're adding a 3 39/100ths to it. And if you notice, there are 2 place value places here, but there are 3 place value places in the second number. So when we line up our decimal points, we have this hole almost. You have to fill that with a 0 so that there are 3 decimal places in the first number and 3 decimal places in the second number. What often people do is take the first number and slide it over to the right and line it up with the second number, and notice the decimal points are not lined up. They lined up the numbers. That's not what you want to do. You want to line up the decimal points first, and then if there are any gaps or holes, then fill in with those zeros. You do not have to fill in zeros on the front end of a number, just an FYI. Here's our first example. We're actually going to call it example 1. And our workspace right here is a grid paper. You can use your line paper and you can turn it if you wish. what I'm going to do first is write down the example one on my workspace. That will help me stay nice and organized. And then all of example one will be right around where I've labeled it on my workspace. The first thing I'm going to do is estimate to get an approximated answer. I'm going to say this is close to 9. So I'm going to say my estimation, and I'm going to draw a cloud. That is symbolizing that it's in my brain. This is what I'm estimating my answer to be in my brain. The estimation is going to be 9 plus 4. So I'm predicting that it's going to be around 13 when I add up these numbers. Now we're actually going to do it. We're going to start with our decimal points. So I'm going to have an intersection, and I'm going to just draw a decimal point. The grid paper might be a little bit light to see, sorry, but you want to start with that decimal point and then fill in your numbers around it. Right below that decimal point, you want the second decimal point for the 4.135, and then fill in our numbers. Now, I am noticing now that there are some gaps above the 3 and the 5. That's where I'm going to annex my zeros, and I'm ready to add. So very simply, we have to carry over the 1, and we will have 13 and 35 thousandths as our answer. For this example, I have a piece of lined paper for us to use, and I'm going to label this one example 2. And on my work paper, I'm also going to say example 2. Again, just like before, I'm going to estimate first. So our estimation, with our cloud around it, is going to be 9 minus 4. And that I can do in my head. I'm predicting our answer is going to be around 5. Now we're going to line up our decimal points. Now the number 9 that I've typed up here doesn't have a decimal point. Where is it? It is right to the right of that 9. And then I'm going to start with my decimal point. Notice my decimal points are on the actual line, so I can use the columns as my place value places. And again, I'm noticing that there's only 1 place value place versus 3. So I'm going to annex 2 zeros so that they all have 3 place value places. And now I'm ready to subtract. I cannot subtract 0 from 7. I cannot subtract 0 from 8. So I have to go over to the 9 and do some trading. So I'm going to put a 10 in the tenths place, but I'm going to have to trade again. And that's going to put 10 in the hundredths place and 9 in the tenths place. Now I can subtract my numbers. My decimal point comes down as well, and I have 6.13. Is 6 close to 5? Absolutely. If I had changed this to a 3, I would have gotten 6 exactly. Again, estimation is just an approximation of how big the number or answer should be. So one last thing is just a reminder that sometimes it's not just going to be a solve this problem. Sometimes if there's some context to it. By context, I mean a situation, a story. Sally is selling tickets to a concert, and how much money is she going to make? So remember the cube strategy poster that we have done in class. That is going to be huge whenever you do any kind of word problem. And also start to recognize some key words in word problems that tell you whether to add or subtract. We're going to be doing something later that will organize this information, but for right now, just start to recognize those keywords. And this is a problem that I'd like you to do first, so I'd like you to pause and try it on your own, and then I'm going to come back and then you can replay and make sure that you are right. This is actually taken from the page in your lesson, which is a Got It, which is Got It G in your workbook. And Jonathan is traveling for work. This morning his GPS indicated his total distance to his destination, 589.4 miles. Before lunch he drove 208 62 hundredths miles. How much farther does Jonathan need to travel? So I want you to just solve that problem in your notebook. Hopefully you have enough room on page 6, and then push play when you're done. Okay, here we go. In this kind of problem, I'm going to use my cube strategies by circling the numbers that are important. And I'm going to be underlining the question, how much farther does Jonathan need to travel? I'm also going to look for keywords. There's a total distance being talked about, and then in the question it says how much farther. So it seems like we're given the total, but then asked for a part of that total. So oftentimes when I'm given a part and total story, I like to draw a picture to make sure that I'm thinking about it correctly. So this rectangle could represent his total trip, his destination. And the total we're seeing is that 589.4. He already drove some of the way before lunch. He drove the 208 and 62 hundredths miles. And we want to know, what's the rest? How much farther does he have to drive in order to get to his destination, which is work? So how much farther is a key word that will mean subtract. This is a subtraction problem. And now we have all the pieces that we have. We've evaluated what to do, and now we have to solve it and check. So I'm going to set up, this is problem G on my work page. And so I'm going to start with the total, which is actually, I'm going to start with my estimation, sorry. And that estimation is about 600. And we're going to be subtracting about 200. Notice, very quick, and I'm predicting about 400 miles. Now we're going to set up our actual problem to solve. We're going to start with our decimal point. So we have 589.4, and then our second number is going to be 208 and 62. I notice right away that I have a gap over here. I'm going to have to annex that 0, and now we can subtract. Cannot take 0 from 2, going down. So we have to trade, and that becomes a 10, and the 4 changes to a 3. 10 minus 2, we have an 8. Next place value column, 3 minus 6, we cannot do, and so we're going to make another trade. And 13 minus 6 is 7. The decimal point comes down. Don't forget that. 8 minus 8, 0. 8 minus 0, 8. And 5 minus 2 is 3. Now, I'm glad I did that. Did you see how I said 7 at first? Say I accidentally added. Forgot what I was doing for a moment. My estimation says 400. 470. That's not as close as it should be. So that is a clue of why estimation is so important. 5 minus 2 is 3. 380 is a lot closer than 400. 380 is a lot closer to 400. So our final answer, we always have to come back and write our answer, especially always with word problems, with the unit. So that is what we would add as our miles, and we are done. So that is my mini lesson on adding and subtracting decimals with a little bit of estimation beforehand there. We are going to practice this more, and I look forward to seeing you tomorrow. Bye-bye.